How do I create a PWM object? A PWM object is created by saying GPIO.PWM. I'm going to use the PWM class to create an object, PWM class, in the rpy.gpio library, which I'm commonly referring as GPIO. So GPIO.the class, I'm going to use the class, and I'm going to pass these parameters to the init method, right? I'm going to pass these parameters. The parameters that it requires are the pin number for the PWM that you're using, that is pin number 19, and the frequency that you are going to maintain for the entire PWM object. So let's say I want to maintain a frequency of, let me say, 1000 hertz. All right, so that's the frequency that I want to maintain. Okay, so it's a mid-frequency range, not a very high frequency nor a very low frequency. Okay, it's a mid-frequency. All right, so I'm going to create an object. So if I have to create an object, which means I need to store it in a variable or store it in an object, I can say PWM_obj. So I created it using the PWM class. I passed these parameters, which went to the init method of the PWM class and returned an object. It created an object for you, which can be, you can use this object to, you can use now this object to access the methods of the PWM class in order to do whatever you want to do. So let's say, for example, so my 19 pin is now going to be defined as a PWM pin, or it's going to be used as a PWM pin in my program, which means I need to say, all right, pin number 19, you are a GPIO pin for, you are the GPIO pin, or you're the chosen one for my program. Now, I want you that now when you start up, what should be the voltage that you are going to give at the start? That I need to say. So I need to say PWM_obj. I need to say dot start. I have to use this method dot start. I have to use this method start, which is there in the PWM class. I need to use this method start and say, okay, boss, please start at a voltage of, let's say, 0. Or this is not a voltage actually. This is called as duty cycle. So what is duty cycle? This is duty cycle. Duty cycle is equal to on time divided by total time. On time divided by total time. So what is on time and what is total time? Okay. So let's say, for example, I told you if your switch, you switch it on for switch it on for a longer time than you switch it off, that means the voltage will be at it will be closer to the maximum than closer to the minimum. But if your off time is more, then it will be closer to the minimum than to the maximum, right? So we have a parameter for duty cycle, where duty cycle is on time divided by total time, where if you switch it on for 1/4 of the time, let's say if it is on for 1 divided by the total time is 4, so that means off time is going to be how much? If this is 1 and total time is 4, then off is going to be for 3, right? So that means 1/4. What will be the voltage, or what will be the duty cycle? The duty cycle, or what will be the voltage which comes out? It is going to be just 25%, right? It is going to be 25%, right? Now, what if my on time was 0 and total time was 4? Duty cycle is going to be 0. That's exactly what happens when you say duty cycle 0. But if you say on time, so if you say 50%, that means it is 2/4. That means on for 2 times, off for 2 times, but total time will be 4. So that is duty cycle. So initial duty cycle is 0. Now if you want to change the duty cycle during the course of the program, you can do something like this: PWM_obj dot change duty cycle dot change duty cycle, and you can give whatever cycle you want. Let's say, for example, if I give 100, which means it will be high. If I give 10 or if I give 25, it's going to be 25% of the maximum voltage. The voltage that comes out from that particular pin is going to be 25%. All right, now because I want to see a constant variation, I want from low to high. If I want to see it, then I need to use a for loop. I need to use a loop, right? I'll say for I in range, from what value to what value. Let's say I want to start from duty cycle that is 0. I want to go up till 100, and I want to go in steps of, let's not make it 1, let's make it 5. In steps of 5, right? PWM underscore obj dot change duty cycle. Instead of saying 25, I'm going to say I, because I is going to be 0, 5, 10, 15. So it's going to change up till 100. Correct? Right? All right. So it's not going to be up till 100 because 4 is, you need to say 101, right? 100 plus 1 is 101. Dot change duty cycle. That's I. Okay. But then you will not be able to see it if you do not give a small delay. So I'm going to give a small delay. I'm going to say time.sleep. Sorry, time is from time. I've imported sleep, so I can use sleep method directly. I can say sleep for, let me say it's in seconds, right? So let me say 0.2 seconds or 0.3 seconds. That's it. I don't want for more. I don't want to wait for a long time. Okay, now, so that's about from low to high. And let me make one from high to low also. So let me say for I in range 100 to 0. I want to go down in steps of -5. Of course, I want to change PWM underscore obj dot change duty cycle change it by I again, and of course give a small delay of 0.3, right? Okay, so I'm going to save this and I'm going to run the code now. So first of all, let's check if there are any errors. No, there are no errors, thankfully. So what I can do now is show you how to connect the particular pin, and let's see the output on the Raspberry Pi itself. Correct? Thank you. All right, just let's have a look at the PWM for now. For now, I'll remove these this button which I've already connected before. I can just remove that out. I just need the LED. As you can see, the anode of the LED. Let me connect. Oops. Let me connect the. Yeah, this is the anode of the LED. I'll connect it to the red wire, and the cathode I connected via the resistance. I'm connecting it to the port which is there at the bottom. And of course, I need to connect this to ground. So ground can be pin number 6, which we used last time. Board pin number 6. So that's 1, 2, 3, 4, 5, 6. Board pin number 6. But the one which is for the PWM is pin number 19, which, as I had said, it was 3. This is the third pin from the bottom. That was what we saw. If you remember in the diagram, GPIO 19 was the third pin from the bottom. That is pin number 35, board numbering. So I'm just going to connect that up. All right. Okay, and let me run my code and let me check what exactly is happening with this particular code. Okay, so I'll go back and I'll run my code and just check it out. Okay, so, oops, just a second. Just give me a second, 1 second. All right, so we're gonna have this. Let's say I'm running that F5. Okay, see, can you see the intensity varying from low to high, and then it will go down. Okay, so it'll become highest, and then it's going from high to low, 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 and then 0, and then again. Okay, it's gonna take some time to go up to 0 because I've given a little bit more delay. 0.3 is a little more for it. Maybe I should give it a 0.2 delay. And then once it goes down, completely down, it will come up again from low to high. See? Okay, so this is about a pulse width modulation. Okay, but of course we haven't done this constantly, right? In our code, what we have done is we have made it from low to high, and then we have made it from high to low, and the program stops there. Do you want it to happen again and again? Then put both the for loops should be put inside a while true, right? So I'm going to put that in while true. I'm going to modify my code. I'm not going to show that to you now, but I modified my code in such a way that it goes from low to high, okay? And then it goes from high to low, and then from low to high again, and then from high to low again. Can you see that? And then again from low to high. So that's what happens. So I'm not really sure if you can see that in the video. Yes, that's quite clearly visible. High, and then from high it goes down to low, and then that's 0. Perfect. Right. So this is about a PWM which we have right now.